Okay, so in the previous discussion, we have seen the various step regulation, right? Arithmetic progression, geometric progression, and harmonic progression, and its definition, as well as we have taken one numerical. Based on that, we have solved to see various conclusion, whether at what RPM range that step regulation law is feasible or not. We have seen all the conclusion, right? So based on above discussion, out of arithmetic, geometric, and harmonic progression, which type of progression law can be used or can be feasible at this stage to design any kind of machine tool gearbox? Out of three step regulation law, you have studied arithmetic progression. Next question arises frequently. Out of three, you have choose geometric progression step regulation law for designing of any kind of machine tool gearbox. Yes, but we need to see that whether it is feasible or not, or why we go for geometric progression, why not harmonic, why not arithmetic. Okay, so I will just summarize your points, right? Just overlook on the table, right from arithmetic. Okay, Ankush said multiple speeds can be obtained at different stages. यहाँ देखो अरिथमेटिक प्रोग्रेशन का टेबल दिखाई दे रहा है सभी को. अभी देखो यहाँ पर लोअर स्पीड स्टेप में देखो 30 है, 2 नंबर का स्पीड है 61 है. मस्ट मीन्स क्या हो रहा है, ऑलमोस्ट डबल हो रहा है स्पीड. क्या हो रहा है, ऑलमोस्ट डबल हो रहा है. तो यहाँ पर देखो डायमीटर रेंज, देखो डायमीटर देखो 212 और दूसरा डायमीटर है 103. मीन्स ऑलमोस्ट डायमीटर का भी जो है वो डबल हो रहा है. बिकॉज देखो यहाँ पर फिर इसका मतलब क्या हो रहा है कि वी नीड टू पुट more speed steps in between 30 and 60, right? Then only you can turn the rest of diameter object, isn't it? And if you see the higher spindle speed steps, right from N9, N10 and N11, यहाँ पर देखो डायमीटर 22, 20 और 18. मीन्स क्या हो रहा है, इट इज लुक्स लाइक अप्रोक्सीमेटली सेम. मीन्स क्या हो रहा है, यहाँ पर देखो 281, 312, 344, ये डिफरेंट स्पीड है, बट डायमीटर रेंज तो एक ही है अप्रोक्सीमेटली. सो दिस स्पीड्स आर रिडंडेंट. ये इसके ऊपर का कंक्लूजन. ऑल ऑफ यू एग्री विथ मी? नेक्स्ट, अभी ज्योमेट्रिक में क्या हो रहा है. ज्योमेट्रिक में देखो, ज्योमेट्रिक का दिखाई दे रहा है टेबल. व्हाट इज N1? N1 इज 30, N2 इज 37. मीन्स देखो स्पीड इतना कुछ ज्यादा रिड्यूस नहीं हो रहा है, ओनली 7.3 RPM रिड्यूस हो रहा है. बट डायमीटर देखो 212, उधर भी 212 था 30 RPM के लिए, बट उधर 60 RPM के लिए सेकंड RPM कितना था, 60, और डी कितना था 103. मीन्स ऑलमोस्ट डबल, हाफ हो रहा था. यहाँ पर कितना है 170. मतलब इतना कुछ फर्क नहीं पड़ रहा है. It means it is quite better as compared to arithmetic. That is your conclusion. ठीक है. और हायर स्पीड के लिए देखो, हायर स्पीड के लिए क्या है, N9, N10, N11. देखो यहाँ पर 33, 27 एंड 21. ठीक है, ये भी क्या है, अप्रोक्सीमेटली सेम है, पर स्पीड भी देखो, स्पीड भी चेंज हो रहा है. मीन्स यहाँ पर हम क्या बोल सकते हैं फिर से, the speeds, higher spindle speed steps are the redundant, isn't it? But it is quite better than that of the arithmetic progression, isn't it? And one more advantage is, at every spindle speed steps the phi is constant, isn't it? Means exact phi we got, means the ratio of two consecutive spindle speed steps is constant, 1.26, isn't it? So that's why one of your friend is right in the chat box, it get the better compact gearbox design. So how will you get the compact or better gearbox design? When you kept the phi is constant, and when the phi is constant, when the two successive spindle speed steps ratio of two successive spindle speed steps is constant, then only we can say that the phi is constant. Means what? जो भी हम स्पीड बढ़ा रहे हैं और कम कर रहे हैं, its range is fixed, isn't it? Either उसको डबल होना है या हाफ होना है, but its range is fixed. If you see in previous cases, very drastic speed is changing, drastically speed is changing. But in case of geometric progression, because of phi is constant, the speed is not drastically changed as compared to arithmetic, isn't it? और last वाला जो है harmonic. In harmonic progression, if you see at the higher spindle speed steps again, at 30 rpm 212, at then the next speed is 32, only 2 rpm speed is reduced, increase, but the diameter range is again quite different than that of the first. And if you see in the higher spindle speed steps, isn't it, and diameter difference, if you see, it is almost constant, isn't it? So यहाँ पर क्या हो रहा है, उल्टा हो रहा है सभी. This at higher spindle speed steps you got the feasible diameter range, okay, 71, 53, 35 and 17. But in case of lower spindle speed steps, we need to add in case of higher spindle speed steps, we need to add more spindle speed steps, means like N9 और N10 देखो, N9 कितना है 90 है, N10 कितना है 121. So diameter देखो 71 है, इधर कितना है 53 है. Okay, so we need to add more spindle speed steps at the higher side of the spindle speed steps, and vice versa. In case of lower spindle speed steps, these are the redundant spindle speed steps. Means what? 30, 32, 36. ये quite approximately same है, isn't it? And diameter difference जो देख रहे हो आप, it is quite same. It means 18, 18, 18, 18 up to N5, isn't it? So same diameter difference we got at the lower spindle speed side, and we need to add more spindle speed steps at the higher side. Okay, these are the conclusion. Next point is, so that's why we have selected geometric progression. Then we need to see that why we are selecting geometric progression, isn't it? So there are various factors, and after studying that factor, you come to know that the geometric progression is only the step regulation law to design any kind of machine tool gearbox. So one of the factor is that in the geometric progression, constant loss of economic cutting speed we got. What we got? Constant loss of economic cutting speed we got in case of geometric progression only. Why we can say that this statement, constant loss of economic cutting speed? Because phi is constant. Ratio of two successive spindle speeds are constant. That's why we can say that the constant loss of economic cutting speed means what? V, isn't it? So यहाँ पर graph है, we just see the graph. On the y-axis cutting speed V in meters per minute, on the x-axis workpiece diameter that can be turned on the machine tool, okay, specifically. So Nk is the minimum speed and Nk plus 1 is the maximum speed, isn't it? Here Vk is the minimum cutting speed and Vk plus 1 is the maximum cutting speed. And in between that, if you take the average of Nk and Nk plus 1, we got the optimum speed as well as optimum cutting speed, isn't it? So the difference between the actual cutting speed and the optimum cutting speed is known as the loss of economic cutting speed, isn't it? Your actual cutting speed may be minimum Nk or maybe Nk plus 1. That will be your actual cutting speed, isn't it? In terms of Vk or Vk plus 1. That is your actual. Means actual. जो machine में मिल रहा है हमें, that is called actual. Okay. So the algebraic difference with geometric in geometric progression, the difference between the actual cutting speed and optimum cutting speed is known as the loss of economic cutting speed. The definition of loss of economic cutting speed is that the difference between actual cutting speed and the optimum cutting speed. Okay, so you know that V means what? Vk means what? Pi d n1 upon 1000, isn't it? And Vk plus 1 means what? Pi d n plus 1 upon 1000. हम क्या लिख रहे हैं? सिर्फ कटिंग स्पीड का फॉर्मूला लिख रहे हैं, पाई डी एन अपॉन 1000. यहाँ पर भी पाई डी एन अपॉन 1000. सो हम वीके के लिए लिख रहे हैं, मीन्स मिनिमम स्पीड. सो इसके लिए हमने यहाँ पर n1 लिया है, और वीके प्लस 1 के लिए लिख रहे हैं. सो इसके लिए हमने यहाँ पर क्या लिया है? n plus 1. Okay, so and in between that means what? You can say that Vk is less than V optimum is less than Vk plus 1. That is the formula, and we wrote in terms of cutting speed. Okay, so again we come to know that V optimum. What is V optimum? We can take pi d upon 1000 constant. Okay, so algebraic, as I told you, the algebraic summation of nk plus 1 divided by 2 will be your optimum cutting speed, isn't it? So your actual cutting speed may be Vk plus 1 or Vk. So if you take the algebraic or the average of the Vk or Vk and Vk plus 1, if you take the average, then you'll get the optimum cutting speed. Very simple. Okay, so how to calculate V optimum? V optimum is equals to pi d upon 1000 into nk plus 1 divided by 2. We take simply average. Okay, so next is how to calculate V max. अभी V max कब रहेगा? When to take the difference, है ना? Difference जब लेंगे तभी क्या मिलेगा हमें? Maximum cutting speed. Maximum cutting speed. Pi d upon 1000 nk plus 1 minus nk will get divided by 2. Okay, difference जब लेंगे हमें उसमें क्या मिलेगा? V max मिलेगा, maximum cutting speed. याद रखो, optimum cutting speed कब मिलेगा? When you take the average of both the speed, because your actual speed may be nk or nk plus 1. Okay, but when to get V max? When you take the difference, isn't it? When you take the difference, pi d upon 1000 nk plus 1 minus nk divided by 2. Then again putting the values in the V max equation of the optimum, means nk का value v का value put करें हम in terms of nk. So nk plus 1 minus nk divided by nk plus 1 into V optimum. Okay, तो सिंपल हमने क्या किया, ये वाला जो वैल्यू है V1 nk और nk plus 1 का, वो यहाँ पर पुट किया, और we got the value of V max. So V max is equals to nk plus 1 minus nk divided by nk plus 1 into V optimum. And lastly, in terms of phi, of nk plus 1 upon nk means क्या हो गया? Ratio of two successive spindle speeds, isn't it? Means maximum speed upon minimum speed, will get phi. So phi minus 1 upon phi plus 1 into V optimum, that will be your equation of maximum cutting speed. So from this equation, constant loss of economic cutting speed, ये कब रहेगा? ये पहला फैक्टर जो ले रहे हैं हम, एडवांटेजेस ऑफ ज्योमेट्रिक प्रोग्रेशन, व्हाई द geometric progression can be used for designing of machine tool gearbox. Why it is so? So maximum, we got the constant loss of cutting speed or maximum loss of cutting speed when the phi is constant, because maximum loss of economic cutting speed is directly proportional to the phi. Okay, and when phi is constant, In geometric progression, phi is constant. So that's why geometric progression should be used while designing of any kind of machine tool gearbox, because in that progression only we got the Vmax value, perfect value of Vmax, isn't it? Are you getting or not? Are you with me? Pranav Jadhav, give your response. Are you listening me or not? You haven't give anyone any response. Yeah, Hari Khose says yes. What about other? If you have any doubt in constant loss of economic cutting speed, you can ask, or you put your question in the chat box. We will discuss once again. Or give your response, understood or yes, whatever. Yeah, Ankush, I got the response from Ankush. B20, B14, B30. Yeah. So on the basis of that, I will moving ahead for the next topic. Yeah, Akash Yadav, Pranav Jadhav, Pranav Ware. Okay, so one more advantage, keep in mind, constant loss of economic cutting speed we got in the geometric progression, because cutting speed, maximum cutting speed is dependent, totally dependent on the phi. And in which step regulation law phi is constant? Answer is geometric progression. So that's why we have to choose the geometric progression. Okay, so this is the first criteria. Next, in another advantage is better design feature. Better design feature. Okay, so in there are two diagrams are there on your screen. In first diagram, the axial distance is more, or you can say radial distance also it is more as compared to the second diagram. Okay, second diagram quite compact and convenient, okay, to design. So better design feature we got in geometric progression because phi is constant. Because phi is constant, मतलब क्या होगा कि रेशियो ऑफ टू सक्सेसिव स्पिंडल स्पीड इज कांस्टेंट. अगर स्पीड कांस्टेंट रहेगा मतलब क्या रहेगा कि नंबर ऑफ टीथ अवेलेबल ऑन द गियर्स that is also accurate. Means what? We can predict the speed, whatever speed we got, because we know that the phi is constant. So we need to control over the number of teeth available on the gears. So on the basis of that number of teeth, so we can control axial dimension as well as radial dimension of the gearbox. So that's why we get the better design feature while in case of geometric progression. So gear shifting time consuming, convenient and economically. Then the standard values of geometric progression, that is phi. You might have been seen that standard values of phi in DME 1 in the preferred series. Yes. So write down this, or you can take the snapshot of this slide the phi 40. So R is equals to 40th root of 10, 20th root of 10. So these are the values of phi. So in the numerical, if the phi 40 is given, so ultimately you need to calculate the phi value is 1.06. Okay, and maximum value of phi is 2, phi 10 by 3. Okay, so and again keep in mind that always value of phi is in between 1 to 2. Okay, so try to take the snapshot or write down in your notebook that standard values of geometric progression, that is phi is equals to Rn raised to 1 upon z minus 1, and standard values of Rm for various machine tool like lathe machine, milling machine, shaping machine, drilling machine and grinding machine. Okay, and the recommended value of phi also given for heavy duty, large duty, medium size and medium to small size. Okay,